For project 4, I've slightly modified my project 3 code. In the first minute, I'll quickly explain and summarize what the model is and what it is doing. So we have a list of vocabulary and then the list of training sentences. And the goal for this model is to generate text given one or two, prompts. And we create a simple model where we have a hidden layer and then an output layer, right? The model is going to give predictions for each vocabulary, how much, what's the probability of that vocabulary being the correct, the next generated word, right? So that's the model is going to do. So we have the data set and data preparations, and then finally we are running through the training, and then that once the training is completed, then we have a function that's going to get a prompt, and then it's going to generate a sentence here. So moving on to project 4, what I've done is I've taken a bunch of test sentences, and if you see here, I am giving the number of token to be generated as 1 and 2, a mix of such tokens, right? And also I'm passing the models as a parameter. So basically we are passing in the model with which this is supposed to generate, right? If we run this one, we get the output, and then from here we come to know that, like, okay, 10 out of these 13 sentences actually make sense, which are correct, and so the accuracy turns out to be 76.92%. So this is the base accuracy when the model is all trained and no neurons have been damaged, right? So now if you quickly look at the parameters of the trained model, we see this hidden weight, hidden bias, output weight, and output bias. We know this, right? Because we had an hidden layer and then output layer. And in the hidden weights, we see the size of 1000 by 5. Again, this makes sense because we are passing in 5 inputs, and then we have the hidden layer of 1000 neurons. So it's going to have 5 into 1000, 5000 different weights. Similarly, for output, we are outputting 48 different vocabulary words, right? So, and then converging from 1000 to 48, it's going to be 48,000 weights for output layer. And when I say damage, what I'm doing is I am randomly choosing these weights, and then I'm setting them as 0 here, right? So we create a custom function called as damage neurons. It's going to get 2 inputs. One is the layer and then the percentage of damage, right? So we are going to damage the hidden layer weights separately and then the output layer weights separately, just to compare, right? And then the percentage, right? If I pass it as 10, so what it's going to do is it's going to randomly pick 10% of the weights in hidden layer, and then it's going to set the weight to 0. So that particular weight has, reduces the importance of that particular input to the next layer, right? And the same thing for output, right? So once this function is defined, then, and this function is actually what it's going to do is it's going to copy it's going to deep copy the original model, and it's going to create a model, and we are going to modify this model, and then we are going to return this model as an object, right? So here, if we see, we call the same test accuracy function, but we are passing in this damaged neurons of hidden. So this is in turn is going to return a damaged model where it damages 10% of the hidden weights, and then it's going to run the text generation, right? And we calculate the accuracy for this, and we see that only 8 out of 13 is correct, right? So the accuracy is 61.5. Similarly, we do this for 20%, 30%, 40%, and then 50%. And then we repeat the same thing for the output layer, right? So same thing, 10 to 50%, right? And then we are plotting a graph. In the x-axis is going to be the percentage of neuron damage starting from 0 to 50%, and then y-axis is the accuracy, right? So we have 2 legends here. One, the green one is going to be the hidden layer damage, and the output is going to be the red graph, right? So both start with the base accuracy of 75 something, and then they drop, right? Now, what's very interesting to me is that the hidden layer one is dropping gradually, while the output layer has a slightly higher accuracy when the damage is 40%, right? The reason why I wanted to compare between hidden layer and output layer is because I remember reading from those papers for project 2, where we were talking about damaging neurons. I think the article mentioned that when we damage the output layer, the model exponentially performs bad compared to the hidden layer. Thank you.